This is your last chance. After this, there is no turning back. You take the blue pill, the story ends. You wake up in your bed and believe whatever you want to believe. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. Remember, all I'm offering is the truth, nothing more.
In this video, we're going to do some basic problems and then, inspired by that clip, make some decisions. I'll take some examples that I found in various books, random books, and we'll work some problems mostly correlated to present worth. Though the first one up, which I took from this book, found randomly on the internet, is this problem. So here we're considering a 5-year budget. So we're looking at a 5-year time frame, and we're expecting to have $10,000 spent in year 1 and 3, and we want to know how much can we spend in year 5 if we have $25,000 right now to put into an account that makes 6% annually. In these problems, it's always valuable, especially word problems, to kind of identify the relevant information. So 5-year time frame, so our in is 5. Our present worth, right, where we have money we're going to put into an account, is $25,000. So our present worth is $25K, which would be a positive, right? And then we're going to have these $10,000 expenditures, year 1 and 3. And of course, I is 6%. So drawing the cash flow out, look like this. And our goal is to find this amount in year 5. So future worth 5 equals what? We'll say future worth 5 equals X, right? And the way we're going to solve that is we're going to set these two equal. So at I equal to 6, right? At I equal to 6, the sum of all of these future worths is going to be the present worth. So we're going to take this $10,000 and move it over to year 0. We're going to take this $10,000 in year 3 and move it over to year 0, and then take that out of the $25,000 present worth that we currently have. And as long as we put the factor in here, because what we're essentially going to do is bring this over, right? But there's going to be a factor there. So with that factor, then we'll have all present worths, and then we can solve for this X. So sum of all of those is going to be what we have now. But right now we have $25,000. 1 year from now we're going to spend 10K. 3 years from now we're going to spend another 10K. Note that there's no negative sign here because this is already on the other side of the equation. If we were solving this all on one side, then it would be plus 25K, minus 10K, minus 10K, minus X, but it's already on the other side of the equation, so it's just 10K. And then here's what we want to find, right? As always, and I'm not sure why, right? We always want to solve for X. So if we were going to do that, I skipped a step or two, but you can follow along, right? Here's the X we're solving for. There's present worth. Here's the payments that we made, and it's negative now because they're on the same side of the equation in year 1 and 3. And then all you have to do is fill in these factors. So I'll go to 6% table, and we grab our P given F factors from there, plug them in, right? So here are the factors. And then we're dividing by the factor for year 5, which is here, and that gives us this answer. We know this is actually in thousands, right? Here's the thousands. So there's your answer. Some other book that I borrowed problems from for this video is this one, Engineering Economic Analysis. And the first problem up is a firm is considering which of two mechanical devices. So we have two devices. They both cost $1,000. They both are going to last 5 years. And the first one, you can expect it's going to save you $300. So there's its benefit, right? The second one, device B, is going to save you $400, and then it's going to decrease by $50 every year after that. In this one, we're using 7% as our value of money, as our interest rate. So what are we supposed to do here with this problem? Well, what we're supposed to do, right, is compare present worth, right? So what we're going to do is we have to calculate, it's a two-step problem, right? You calculate present worth of device A, and then you calculate present worth of device B, right? And then whichever one's better, you choose that. So the last one I did using tables. This one I'm just going to solve it using Python. So, and it also helps, even if you don't know Python, you get the logic, you can get the logic of what's going on. So let's say, hypothetically, this is not the answer yet, but let's say that the present worth of the first alternative is $10,000 and the second alternative is $8,000. Well, which one are you going to choose? Well, obviously, right, if the present worth of the first one is greater than the second, then the first alternative is better, and that's what you're going to choose. Contrarily, if the present worth of the second one is larger, then obviously you're going to choose the second one. This may not always be positive, right? And we'll work an example later where they aren't. For this one, let's find out, right? In this case, of course, it chooses present worth 1. Now, if we were dealing with something that comes out negative, for instance, this is negative and this one is also negative, but you're going to choose present worth 2 because present worth 2 is less negative. So in this example, we're not making money, but we're going to reduce our costs in order to maximize, right? In economics, that's the whole goal, is efficiency and maximization. So in this case, we're going to choose PW2 because it's less negative. So let's go back to our problem, right? I thought the problem read very oddly, right? A firm is considering which of two mechanical devices. So I just scratched out things I didn't like. So a firm is considering two devices to reduce costs. The end. Both cost $1,000. So they're both going to cost $1,000. So our time frame is n equals 5. Right? And then we're going to have to break this down. So alternative 1, which is really device A, is going to cost $1,000. Since both of them cost $1,000, we could leave this out. Right? If it's $1,000 for this one and it's $1,000 for the other one, then the only thing that matters is the benefit of it. But for the sake of getting better at cash flow diagrams and being comprehensive, we'll leave it in there for both of them. So it costs $1,000, and then every year we get $300 benefit. So what's the present worth of all of this? Now, since those payments are the same amount and they come in even increments, then this is an annuity, right? This is an annuity. It's an annual value because we're dealing with years. So this is an annual worth. So since it's an annual worth, then we can solve it using P given A. So here's the $1,000. It's negative, right? All this is on the same side of the equation. We have to keep track of our signs. This is negative. We spent $1,000 and bought this thing. Now we're making money. We're making $300 every 5 years. We value it at 7%, so we're looking for the present worth given annual. Going back to Python, right? And if you don't know how to use Python, you can solve this using the tables like we did in the previous example, or you can solve it using the equation if you want to, or Excel. I'll solve the next one using Excel, as in Microsoft Excel. So here's our rate, right? Here's our rate, 7%. And what I did is I just put in the cash flow. So for this alternative, we spent $1,000 and then we made $300 every year for 5 years, right? 1, 2, 3, 4, 5. Yeah. So 0, 1, 2, 3, 4, 5. Now I'm looking for present worth is the net present value. So often, just like in Excel or in other places, you may run into NPV. This is analogous to the present worth, right? Net present value. So I'm looking for the net present value at my rate, which we defined as 7% for this array of, or this cash flow, right? All these values per year. This one I'm leaving for right now as just minus 8,000. It doesn't matter. That was the previous one. I'm going to overwrite that. So we run it and print it out, and we get 230. So present worth of alternative 1, which is to say device A, is about 230 bucks. So it's going to make us money. It's going to save us money compared to its purchase price. Now we go back to device B, right? So device B, that says device. Device B, it also costs $1,000. But in year 1, it's 400. So we're better off so far than device A. So 400, then 350, now 300. So in year 3, we're only even with, but still better off in the first 2 years. In year 4, it's 250. So we're worse off in year 4 than the other device. Year 5, 200. So we're worse off. So the question is, being better off up front and worse off in the back, is that going to end up being better for us than device A or not? Now, we could solve this in a similar fashion where we take this value and we move it back. We take this value and we move it back, kind of like we did with that very first problem, right? And we move all of these back and then we sum them. We haven't covered it yet, and I'll have a video on gradients, but what this is, anytime, so what we essentially have here is annual value of 400, right? Consider this. We have an annual value and 5 of them of 400. So 400, 400, 400, 400, 400, right? And as stated in the problem, right, it's decreasing by 50. And it starts decreasing here. So there's no decrease here, and then it decreases by 50. And then it decreases by 50 again compared to where it is now, right? So another 50. And then another 50. And then another, right? And that's how you end up with 350, 300, 250, and 200, right? 1, 2, 3, 4, 5. So this is something called the gradient, and it's an arithmetic gradient because it's decreasing at an even amount. Now you don't have to worry too much about that because I will put out and we'll talk about, I will put out a video and we will talk about gradients later on. But just so you know, we could solve it this way, right? Here's the 400 annuity, right? 5 years of 400. And here is where we're subtracting off the 50 from this. So just so you know, we could do this. 1, 2, 3, 4, 5. We could solve it this way. But I already have this set up in Python. So now I'm replacing that present worth 2 that we saw before with this actual cash flow, right? So let me switch back to yellow. So here's the $1,000, and then here's the 400, 350, 300, 250, and 200. So that's our cash flow. And here's where I'm passing it over to net present value so I can calculate it, right? And now this program's going to compare for me. If the present worth of 1 is greater, then let me know what the present worth is and we'll choose it. If, on the other hand, present worth 2 is greater, then we choose that and pass the value to me. And we can see here, obviously PW2 is better, which means that this is the value of present worth of device B is 257, which is greater than PWA, right? Greater than device A. Therefore, we would choose B. So we would choose to purchase device B. From that same book, this is another example. In this case, we have a purchasing agent considering two alternatives. Okay, so we have the Speedy alternative, which is cheaper, so $1,500. Both devices last 5 years, and Speedy will pay you back, right? It has a salvage value, so at the end of 5 years, you can sell this for $200. You know, this mailroom equipment, you could sell it. Now, Speedy's going up against Allied, who's more expensive. $1,600, also going to last 5 years, but just like its first price, its purchase price, its salvage value is more than its competitor. Right? So, is it worth spending a little more up front in order to get a little more 5 years from now? Part of that answer depends on how you value money. So here it's saying we assume 7% again. So we have a 5-year time frame and we're assuming 7%. So n equals 5, I equals 7, and we have to compare two alternatives. So we're comparing Speedy versus Allied. In this case, it's $1,500, right? So that's already in present worth, so there's no factor because it's already present. It's negative because we're on the same side of the equation and we're spending money to buy this thing. And then we're getting money back, but we're not getting it back until 5 years from now. So in order to make these consistent, this is a present worth, we better make this one a present worth. And we do that by using present given future. That should be present given future, right? We're looking for present given future, 5 years, 7%. Now, as mentioned, I'm going to solve this not in Sexcel. Obviously that S should not be there, and I think it's because it belongs here to syntax. Yes. Okay, that would be a way better name for it, but we're going to solve this one in Excel, and we're going to use present value. So here's the rate, this is the syntax, so this is a function in Excel, and we just pass it the arguments that we want. So we're going to pass it a rate, the number of periods, if it's a payment, and by payment it means an annuity, right? Like some kind of recurring payment, so this would be A. Or we can pass it some kind of future value, F, and then there's type, which you generally don't have to worry about, but this is whether you make the payment at the beginning or the end of the period, because depending on how it compounds, it may make a difference. You can usually leave that blank because the default is 0, and in this case we are considering end of the period. So going back to this, we're dealing with two things that are very similar. So in Excel I set it up this way. We can look at them together. So you'll find here I set them up. I don't remember the names of these. Speedy and so this is S and this is A. All right, first cost $1,500, $1,600, salvage value $200 and $325. Where our interest rate is right here in decimal form, 7%, and we're talking about a 5-year time frame. So down here, I said this is negative, right? Because our first cost is going to be negative. So this is negative, and then I'm going with the present value, which is the function I just showed you. And then the values, right? We're passing it the rate, which is 7, and then we're passing it the number of periods, which is 5, and then we're passing it these two values here. Right? So you'll see these two values here, 1, 2. Now, because of the way the function is set up, it's going to give you a negative answer. So what you do to get a positive answer is you put the negative sign in here, That's part of how it's assuming you're going to use this function, but we're not using it that way in this case, right? Because salvage value needs to be positive. So you put that in there to get a positive answer here. So that gives us 1,500 negative, no surprise, right? That's the purchase price. Negative 1,600, no surprise. Now this is the present worth value in year 5 of each alternative of S and A. And then you just add those up. So we shouldn't be surprised to find that both of them are negative. I mean, we're buying mailroom equipment here, so it's not going to make us money. Right? It's a piece of equipment that we need for our business operations. So which do we choose? Well, we choose the least negative one, right? So the least negative one is Speedy, and so we would choose Speedy because it's costs us slightly less. From that same book, here's another example. So a firm is trying to decide which of 2 weight scales, the ideal scale. If both scales have lives equal to 6-year analysis period, which one should be selected? So now they're giving us the information in tabular form. So we have this table here of values. We need to use a 6-year time frame, and we're going to evaluate this at 8%. So n equals 6, I equals 8, and that doesn't have a compounding period stated with it, so we would assume that's 8% per year. Here are 2 choices, Atlas and Tum Tum. So one of them is more expensive, this one, but you get a greater annual benefit, that one. You also get a greater salvage value. So how do we solve this one? We compare their present worth and see which one is better for us. So here's present worth of Atlas versus present worth of Tom, right? The structure of them is similar, where we have the purchase price, which is already a present worth, right? $2,000 is negative because we're buying this thing, and it's on the same side of the equation as the benefits, or whatever revenue money we're going to make. So this one makes you $450, but that $450 is an annual benefit, right? So now to make this present worth, I need P given A. So P given A, 8%, 6 years, and I get $100 back. I don't get my $100 back until year 6. So to make this present, I need this factor. This one works the exact same way, only difference is the values change. So I'll leave it to you to solve this in whatever way you feel is best and see which one wins.
But where they have failed, you will succeed.
What are you trying to tell me? That I can dodge bullets?